Hello, I'm at MC Toon, and it's Tuesday night. And today we've got a debate with Darryl Sheppard. Sheppard. Oh, just a second. Darryl, how are you doing?
I'm doing great. Thanks, Toon. How you doing?
I'm super.
All right,
It's
awesome.
been a good day.
Good to hear.
Well, why don't you go ahead and introduce yourself, and then you can jump right into it.
Yeah, okay. All right, MC Toon. Thank you for having me this evening.
Hey, you're welcome.
Right. My name is Darryl Sheppard. I'm from the United States. I'm from Washington, D.C. And I've been a teacher for the last about 10 years or so internationally. Been all over the world, traveled everywhere. International traveler. And yeah, I believe the Earth is flat.
Right, and what makes you? Oh no, you wanted me to go first, right?
Yeah, sure.
All right. Well, so number one, being a teacher, you should be able to appreciate this. What are there specific topics that you teach?
Yeah, I'm a teacher of English, but
English, okay.
But in the process of teaching English, many conversational points come up.
Okay.
So a little bit of everything. I also taught Spanish for a year in Washington, D.C.
Okay. So a little bit of geometry, about 8th grade geometry is all you really need to test to see if the Earth could be flat. Because the sun is visible and we know where it is. We know its position above the Earth. Regardless of the shape of the Earth, we know it goes between the Tropic of Cancer and Tropic of Capricorn. In the northern hemisphere, if you're north of the Tropic of Cancer, then the day of the June solstice is the closest that it will ever get to you at midday. That's local solar noon. And I've measured the angle to the sun from my place in Minnesota here. And at local solar noon. And then 12 hours later, when the sun is on, if the Earth is flat, the other side of the flat Earth across the North Pole from where I am, it's a certain distance away. It's about 69 miles per degree. I'm 45 degrees from the North Pole, and then it's another 60 degrees to the Tropic of Cancer on the other side there. So we can just do the math to get the elevation of the sun if the Earth is flat at midday. And then we can use that elevation 12 hours later to predict its angular elevation above true level. And if you do that math, it should never go below true level, or never at all. In fact, the lowest it could get from anywhere in the United States, any of the major continents other than Antarctica, is 9.5 degrees above true level. So the sun could never set because due to perspective, no matter how far away the sun is, it's still at a positive angle above the Earth. So there's how it could not be flat. Now, what shape is it? There's many measurements of it, but sometimes I like to look at visual. So let me get this here. There's a flat earther named Dwayne Kellum who sent up a balloon with a camera on it.
Yeah.
Now, one problem that people have is they put just a second. I'm sharing this to you. They send up GoPro cameras because they're cheap and they mount easily to things like that and they're rugged. And that gives you a false curve. So you want to do one of two things. One, you'd have an external reference like a straight edge, so you know that so you know what straight is, right? And then you can measure against that. Or you could use a lens that does not introduce strong barrel distortion. So he used a lens, a Sony FE 50mm f1.8. And right here is from a third-party website. TheDigitalPicture.com does reviews of different camera lenses. This is the amount of distortion added by that lens. Now, you may or may not be able to see on your computer, but there is no major distortion introduced by the lens. So any curve that this camera would image is a real curve, and any straightness that this camera would image is a straight line. You agree? Okay.
Yes.
So so he sent his balloon up to 120,000 feet, and here's a still from there at 117,000 feet, I think. And I can zoom in here a little bit. I drew this yellow line on top of it myself. You can see here on the left, the yellow line is directly on the horizon there. It's just starting to change color. And over on the right side, I did the same thing. And then in the middle, you can see it bows up. It curves up.
Yeah. What is the altitude on the one with the bow?
117,000 feet. And that's on the bottom. I can actually show it to you. It's on the bottom right here of the picture. 117,000 altitude in feet. Altitude meters 35,793. So we can take that same image just to see because when it's wide like that, our eyes are not good at distinguishing curve. So we can do a horizontal compression. When you do a horizontal compression, straight lines remain straight, and curved lines become more apparently curved. So this is what you get when you do that. You can see that curve there. That's the curve of the horizon. So this is available on my website at mctoon.net/Dwayne Kellum, or you can just search for Dwayne Kellum on my website. There's a search feature. So there it is. If the Earth were flat, the sun could never set. And and a photographic evidence of the curve of the horizon.
Okay. You said Dwayne Kellum, you said?
Kellum, Kellum.
Kellum, okay.
Yeah.
All right, I'll take a look at that. Right, you said, okay. Is that it?
Yeah, that's it for now. I like to keep them on point, so if we can have a deeper discussion on anyone in detail, and if we exhaust them, I can bring up more.
Okay, all right.
So if you want, you could present yours, or if you want, we could talk about mine.
Okay. No, okay. I'm going to go on ahead with mine.
Okay.
Okay, so I'm a flat earther with a little bit more of a different perspective. I come from a more I'm a great student of history. All right, so I like to start from looking at the history of our ancient ancestors, looking at the ancient cosmologies of the world. So there's a growing narrative in that's very popular among globe earthers that the ancients were not aware of what they were standing on. They didn't have science, and they didn't know what they were standing on. They weren't able to detect what it was they were standing on. Therefore, they thought it was flat. I would disagree with that. I would say, well, wait a minute. We have, people who built things like the pyramids in ancient Egypt and Pumapunku in Latin America. Angkor Wat is about over 1,000 years old. Hindu temples were carved by hand out of whole mountains. The Babylonians were able to predict eclipses. And many of these monuments actually still line up with the solar solstices. I can't believe that the people who were able to accomplish all that were just simply mistaken. I just don't buy that. The Babylonians had cosmology where they depicted Earth as an upturned plate with a dome, very similar to all the other Mesopotamian cosmologies. The ancient Egyptians also had a flatter cosmology where you have, Nut. The goddess Nut was depicted as the sky, and Shu was holding up Nut, and the god Geb was depicted as the god of the earth. These are all flatter cosmologies that are thousands of years old, and I just don't buy the argument that they just didn't know what they were standing on. As I said, many of these things line up with the constellations, line up with the three stars of Orion in his belt, as above, so below. This is also true of other cultures, such as the Hopi culture in the southwestern United States. As above, so below. These Mesopotamian cosmologies also give us a basis for what finds their way into the Bible as well as the Quran. We find in the Hindu cosmology, we find Bhumandala, which was depicted as a celestial sphere with a central flat plane in the center. Jambudvipa was the central plane, and then Earth is depicted as concentric circles interspersed with saltwater oceans. This is how they depicted the universe. So I like to come from a more spiritual perspective. I don't think that these may sound fantastical to us, but I don't think they're any more fantastical than any other cosmology that scientists in white coats are giving us, speculating about stuff they didn't see. So it's all a story at the end of the day. Nobody saw it. Let's see. Then I want to also present. I want to come with further information, but I think. Well, okay, I can present other documentation. There's the documents, the documents from NASA, the derivation of the definition of the linear aircraft model, August 1988. These documents very clearly say that these documents document the definition and the lunar aircraft model for a rigid aircraft of a constant mass flying over a flat, non-rotating Earth. Page 1. This is repeated several times throughout the paper. In the first line of the second paragraph, same thing. It repeats: flat, non-rotating Earth on several occasions. Not just NASA, but also the FAA, the engineering design of the aircraft dynamics model for the FAA target generation facility. Page 62 says the observant reader will notice that the aircraft equations of motion were calculated assuming a flat Earth. Page 62. Right? We have aero students, flight dynamics. Page 1, they make several assumptions. Assumption number 1, that the Earth is flat. That is i.e. the curve is 0. Number 2, second assumption, there is a non-rotating Earth, i.e. No Coriolis effect. Next paper, the Army Research Laboratory. In their paper, I could send you a link. I could send a link to all these documents.
I've already put them all in the chat. All 44 of them.
Okay. Oh, great. All right. So it is assumed that the transmitting antenna and the target are located above, but near the surface of a flat idealized Earth. Page 7. All right. So there is some kind of documentation that testifies to that. I'm sure people may disagree about what that means. Finally, I just wanted to say that there are several physicists, famous physicists, that also testify to the philosophical validity of a geocentric Earth.
Do you have
For
their
example,
names?
pardon?
Who?
Okay, yeah. Okay, well, we have a quote here from Stephen Hawking, Dr. Stephen Hawking. Knows him, right? Okay, so he says it is not uncommon for people to say that Copernicus proved Ptolemy wrong. That that is not true. One can use either a picture or as a model of the universe. Our observations of the heavens can be explained by assuming either the Earth or the Sun to be at rest. That's Dr. Stephen Hawking. Next quote comes from Fred Hoyle. He said, he repeats basically saying that we can take either the Earth or the Sun or any other point for that matter as the center of the solar system. That's Fred Hoyle. Science writer Kitty Ferguson said that because of the concept of relative motion, no one can prove that the Earth moves. George Ellis is my favorite quote. He says, "I can construct a universe with Earth at the center, and you cannot disprove it based on observations. You can only exclude it on philosophical grounds." And then I have some other papers. I have a whole page of such quotes, varying from commentary on the results of the Michelson-Morley experiment of 1887, as well as other quotes explaining the validity of geocentrism, as well as some other professors from universities, professors of physics. I have another paper that I could present. I think
You've put a lot out there.
Okay, that's it. I'll start there. I just wanted to show that we're not that I'm not a kook who put no thought into this. I'm not a Bible thumping anything. I'm just putting out my experience and my research.
Okay. So how were eclipses predicted with these ancient models?
That was the Babylonians. That was the.
And did they predict accurately the date, time, and location of eclipses?
Yeah. Let me see. Let me find that. Let's see. Let's see. The Babylonians. Yes, I believe they were accurate.
Date, time, and location, please.
Yeah. Hold on.
Yeah.
Okay. Let's see. Yeah. Okay. So by carefully noting local lunar and solar eclipses, Babylonian astronomers were eventually able to predict lunar eclipses and later solar eclipses with a fair accuracy. Yeah.
To date, time, and location.
Right. Their tool was the Soros cycle. Right.
Yeah. But the Soros cycle is a pattern. It is not a geometrical thing, and it only predicts the day, and it's not very accurate. So how did they predict the date, time, and location of the eclipses?
I don't know the exact details of it. I haven't looked into it.
Well, I have looked into it. Maybe in the future, don't bring it up if you didn't look into it.
I'm just going on.
So I'll tell you, Saros cycles are strictly a non-geometric pattern that they've identified. It has nothing to do with the shape of the Earth at all. So Saros cycles are not a flat Earth evidence in the least, even if they could predict the location and time, which they can't. They can only predict the date. The only way that people are able to precisely predict maybe there's others, I won't say only, but the way that NASA does, the way we do in the United States, is by using the ELP 2000 model, which is a three-dimensional geometric model that uses the distance between the Earth and the Moon, and the distance between the Earth and the Sun, and the elliptical orbits of the Sun, the Earth around the sun and the moon around the Earth, to predict the date, time, and location of eclipses, accurate to less than a few seconds. So sorrow cycles doesn't do you any good, and they couldn't get any of the accuracy that we do currently.
Okay, all right. Well, my point was they had a flat Earth cosmology at the time.
Okay, but their flat Earth cosmology had nothing to do with sorrow cycles.
No. It had nothing to do with solar cycles. No.
Okay, so why even bring up sorrow cycles? Because it has nothing to do with cosmology.
Well, they were able to predict. They were able to predict the eclipses at the time, and they had a flat Earth model. That's all I'm saying.
But they're unrelated. I'm able to go to the bathroom, and I own a car. They're not related. You see, there's no relation between them, unless I needed to drive to the bathroom. But I have one in the house. Modern conveniences. So, the next thing you says is ancient cosmologies had thought the Earth was flat, and many of them did. But also, where do these ancient cosmologies? What do they say the sun does after sunset?
What do they say the sun does after sunset? I don't know. Why don't you tell me?
The ancient cosmologies think that the sun goes through tunnels underneath the Earth when the sun sets, because they had enough understanding of geometry to know that if the Earth were flat, then the sun can't just be above it somehow circling. It would need to go lower than the surface of the Earth. So they generally say they go through portals. The Book of Enoch talks about portals. The six portals, yeah. Yep, the ancient Greeks thought that that the sun and moon went through tunnels. So that obviously isn't the case and doesn't work now. It worked then because they were unaware that nighttime for them was daytime for somebody else. But we know that now, so it doesn't work anymore. So we're back to geometry, and there. If you're going to say ancient cultures thought that the Earth was flat, you bring all of it with, right? You bring their maps. Well, they didn't have any maps for the entire Earth, so that doesn't work too well. You bring their idea of the sunset. Well, that doesn't work. Can you replace it with another idea for sunset? Maybe we can get to that later. I can. Mathematical prediction for when and where the sun should set. So ancient cultures.
I'm not trying to make the argument that they were in any way scientific in any way that we would consider it to be, scientific. That's not my argument.
Yeah, I agree. They weren't scientific about it. All they had was, well, it kind of looks flat, and we don't know.
But they had eyes; they could see.
Yeah, and
they all consistently agreed that the Earth was flat as far as their eyes could see.
And they all generally agreed. They all generally agreed that the sun went through portals under the Earth at nighttime too.
Well, I mean, they couldn't see the sun, so
exactly.
Whatever. I'm talking about what they could see.
Yeah, so they were just wrong.
No,
thank you, Phil.
I mean, that doesn't. I mean, we don't throw the baby out with the bathwater because absolutely everything they said was wrong. Do you think the core of truth.
Do you think they went under
the core of truth that they could see?
So they had one thing. Earth looked flat. That's all they had.
Earth looked flat. Okay,
because
I'll go with that.
They didn't have that. Nothing in the rest of their model.
They all saw the flat Earth with their own eyes, and that they agreed upon. That, in my opinion, is a kind of peer review. They saw it.
Okay, all right. Constellations. You mentioned constellations.
Yeah.
And can you send the documentation of the? Do you think that the constellations somehow positions say something? Is that what your point is?
Yeah. What was that? I mentioned Orion's belt. That was the pyramids lined up with Orion's belt, and we have several.
But what does that tell us?
Complexes where that is the case. We have the what was that? Teotihuacan in Mexico, as well as.
All right. My question isn't to give me a list of different places. My question is, what does that mean if these ancient people were able to position things relative to stars? What does that mean?
They were able to line them up, right? You know, according to their observations, they didn't have the technology. They were able to accomplish huge mathematical feats.
Okay.
They were not dumb people.
How is it's not that much of a huge feat to just say, oh, look, on this day, the stars are here. That's not mathematical at all.
They were making observations, and they were documenting what they saw, right?
Oh yeah, so it's just a documentation of what they saw. How does that inform us about the shape of the Earth?
They were all consistent in their description of it. It is flat and does not move as far as they could tell.
But same thing. How are they related? How is that they thought that the Earth was flat, and that somehow they lined up features with stars? How are they related? That it seems to me similar to I have a bathroom and I have a car. What's the relationship?
Well, what I'm saying is, as far as the shape of the Earth, they all agreed upon it all over the world. We have ancient cosmologies from the Hindus, the ancient Chinese, the Aboriginal people of Australia, Egypt, the Babylonians, Latin America. They all agreed on this point. Is what I'm saying. They observed a flat Earth, and that's what they saw.
Okay, but
all over the world, with nobody different on that point.
But that doesn't answer my very specific question. How does that relate? How does that relate to building a monument and lining up with stars?
Okay. Well, I mean, what I'm saying is that these were not what we would call mathematically challenged people. All right. They could make calculations. They were doing what we were doing. They made calculations and they made observations, and they were able to line up these monuments with the stars. I think that's pretty impressive. As well as how they constructed these monuments. We cannot replicate these today.
Okay. Again, how does any of this have a bearing on the shape of the Earth?
Because we cannot replicate it today. That's a big deal.
How does that have anything to do with the shape of the Earth? Whether or not, and I don't know, I don't agree, but whether or not we could or could not build a giant monument, how is that related to the shape of the Earth?
Well, you're connecting the two. I'm not saying that. I'm saying they could do these amazing things. They were not ignorant people.
Excellent. So let's disconnect. All right. So then let's disconnect their Earth looked flat, therefore Earth is flat, with their building of large monuments.
I'm not connecting the two.
Okay, excellent. So,
I'm not making a connection between the two.
How does their ability to build a large monument lining up with the stars have any relevance to the shape of the Earth?
It doesn't.
Thank you. Okay, we can move on. Check. Okay. Constellations don't mean anything. All right. Derivation of linear aircraft. You said the keyword. Now, I said that I posted the link to all 44 of them in chat.
Thank you. Appreciate it.
Do you know why I was able to do that so quickly?
You had it already lined up.
Because I've read all 44 of them.
Good.
So.
And what is your interpretation of them? What do you think that means? What do you mean to you?
Well, I'll give you a little background. I am trained as an engineer. Mm-hmm. Okay, so these are engineering documents. Mm-hmm. So it goes right along with my understanding of engineering. So, do you see what I'm sharing to you right now?
I see it.
Okay.
Nathan Roberts, government documents. I see it.
Yep. Yeah, they're actually from Dean Odell or Dean Odell. He's the one that introduced this derp. So you use the word idealized. I have right here a definition
that was the Army Research Lab.
Yeah, so idealization is the process by which scientific models assume facts about the phenomenon being modeled that are strictly false, but make models easier to understand or solve.
Okay.
All right. Here we go. Number 7, derivation of a linear aircraft. And page 6, just like you said. Also, these other pages, 35, 55, 102. Mm-hmm. and the link that Nathan provided, even Nathan Roberts, and that's not searchable. I found a version of it that's searchable. So the pages don't line up, just a couple different. Anyway, it is an idealization. It, in particular, it assumes the aircraft is rigid. It is assuming the aircraft is rigid. Now, is the rigidity of airplanes a conspiracy, and people are hiding that fact from the public to keep them enslaved somehow, or are aircraft actually not rigid?
You asked me, are aircraft rigid?
Are aircraft rigid? Yes or no?
I would have to say no. They are. They would have to be flexible.
That's correct. And anybody who's ever flown can watch the wings flex as they take off.
Yeah.
So so this document is assuming that aircraft are rigid. Okay. Weird, even though that's definitely not the case. It also assumes the aircraft has constant mass, even though it burns fuel. It also considers the air to be stationary. That means there is no wind. Is there wind? Does wind exist? Of course it exists.
Of course it exists.
So then those three assumptions are put into it, as well as the assumption of the Earth being flat. Now, what this means is they are specifically excluding these things that are not true from the model that they're building here to reduce its complexity. That's why they do that.
To reduce the complexity. So
yes.
they are designing aircraft using things that are not true. Is that what you're saying?
You are absolutely correct. That is what they do.
Why would they do that?
Because of complexity. Here's the thing.
People's lives.
Absolutely, but here's answer this. When somebody, Darryl, when somebody designs an aircraft, are they aware of the wind conditions 20 years later?
No. Of course not.
So you could not include the air conditions when you're designing an aircraft. You must do something. You must just say, well, let's just pretend that there is no wind, and let's do something else to deal with the fact that there is wind. The same thing happens for the shape of the Earth. Now, when an airplane flies over the mountains, does the designer need to have taken into account the specific mountain range that they are about to fly over, and the topography of that mountain range 20 years after the airplane has been developed? Of course not.
Of course not. No.
Same thing. So you need not take topography into account. Same thing. You need not take the curve of the surface of the Earth into account, because it doesn't impact it directly in the design. Same thing with Coriolis. Coriolis is a lateral force that is less powerful than the force of wind that you must take into account. So if you can deal with wind of 20 knots lateral, maybe, then you can definitely deal with the very slight lateral force induced by Coriolis. You don't need to take it into account because Coriolis is dependent on the velocity and the latitude. So how could a designer of an airplane take into account Coriolis when they don't know what particular latitude that airplane is going to be flying over at any particular moment? They don't do that. What they do instead is they deal with it, and they plan so that they can deal with lateral forces, wind being much larger than Coriolis. Right?
Mm-hmm.
Okay. So further, just say here, pages 7, 8, and 24 acknowledge gravity. Now, do you think that gravity doesn't exist?
I do not believe in gravity.
Okay, well then this document acknowledges that gravity exists. Are you willing to accept this document?
It acknowledges that gravity exists.
Yes, it is included it is included in their modeling.
But it is saying that
What? You're talking about their modeling.
Okay.
You're cherry
Okay,
picking.
I'm talking
You're
about the
cherry
model.
picking
Okay,
their
right.
modeling. You don't get to
Yeah,
cherry
yeah.
pick an engineering document. That's not how
No.
engineering works, right?
No.
They're including gravity in this document
Okay.
in
Okay,
their
they're
model.
including gravity.
So
Okay, they're including gravity.
you
But of course, as a flat earther, I don't think gravity's a real thing. No.
okay. So what are you going to do with this document then? Are you going to accept it or reject it?
I disagree. I disagree with your interpretation of the document.
You disagree with me,
I
but you
disagree with
didn't.
your interpretation
But
of the
you
document.
didn't.
I don't believe they're factoring in stuff that's not real. I don't.
But you
know,
didn't read the
I don't
document.
get that. I don't get that.
You didn't read the document. All you
Okay,
did
so
was
what-
quote. All you did was quote somebody else's summarization of the document.
So where does it say this stuff isn't real?
It is an idealization, just like we
No,
went
that's
over.
not-
Just
no,
like we
that's
went
one-
over.
No, that's one paper you picked out the word idealized. There's 44 of them here. There's there's one document here that uses the word idealized, and then you smear that. You use the word idealized, smear everything else.
This particular document doesn't
This was
use.
one document that says idealized. The other ones don't.
Let me finish.
Anyway,
This
go ahead.
particular document does not use the word idealized. The idealization that I have at the top here talks about the technique that they're using in all of these documents.
Okay, where did it say that? What are you getting that from?
That's part of engineering. You not being an engineer, I would not expect you to have this kind of background. You don't do. Just wait. You don't do engineering, right? You're a
I'm
engineer.
not an engineer.
Okay.
I'm not an engineer. No.
Since you're not an engineer, I don't expect you would have been exposed to these types of things, the trade-offs and idealization that you need to do when you're designing things in engineering. Okay. But you do trade-offs as a teacher, right?
Yes.
One trade-off you would do as a teacher is you might move at a slower pace for your entire class to allow the median students to keep up. Even though some of the students are faster learners, you slow down your pace. You have idealized and made trade-offs in your teaching pace for them. You also, knowing you have to, there are going to be students that cannot handle the particular rate, and maybe they need to be moved down to a different class. They need to be taught differently. They need to be tutored or something. Again, you've made a trade-off. Engineering is similar. You make trade-offs. So
I got you. No perfect solutions.
Yeah. And like we went over already, the assumptions in this particular document include rigidity. So so we know for a fact that the list of assumptions is definitely not true. It is a known false assumption to simplify the modeling. Right? Now, which other one would you like to look at?
So you're saying that they design aircraft upon factors that are not true, and they write it in the paper and repeat it several times. That's what you're telling me.
Yeah.
That's normal.
That is normal engineering.
Okay. All right. Okay. Anything else you want to?
Well, you brought up a couple documents of this list.
Okay.
Do you have another one you want to look at? I can tell you they're all the same, and I can send you the link if you want. You can read my summary of them and see if you agree later, or we can look at them now. It's up to you.
Okay. Okay. Let's move on.
Okay, you don't want to stick with this anymore? Okay.
If you want to,
I'm fine. I'll tell you what. I'll send you that. I gave you the link in Facebook there, and you can have a look on your own time. So okay.
Got you.
There. Okay, so then you talked about different physicists that were geocentrists.
Oh yeah.
So, geocentrists are not flat earthers. They think the Earth is spherical, and that
some of them do,
and that the Earth is at the center. That's the general idea of geophysicists. But when you quoted Stephen Hawking, he does not think the Earth is flat.
No, I'm not saying he does. I'm talking about geocentrism. I'm just talking about geocentrism, the idea that the Earth could be in the middle. That's not a flat Earth argument. I'm just saying geocentrism is not philosophically untenable. That's all I'm saying.
Are you suggesting that Stephen Hawking thought that the Earth was the center of the universe?
I don't know what the context of that particular quote was. But
when you're going to quote somebody, you should know the context.
I just got it off this website where there was a bunch of quotations. I don't know.
How about this? Don't just get it off the website. Actually read the context so that when you quote.
He just said, a lot of people, it's not uncommon. I can read English. I am an English teacher. Okay. He said it is not uncommon for people to say that Ptolemy proved, that Copernicus proved Ptolemy wrong. That is not true. I can read English. I don't,
Okay.
Okay.
So
that is correct. And other people would agree. I repeated Fred Hoyle. What? I don't understand the context of.
So here's the deal. To cherry.
It's not untenable. You can pick any point in the universe.
All right. Let me explain here. To misquote somebody, to cherry pick out of context and have suggesting that they have a belief other than their belief or hold a position other than their position is incredibly dishonest. Stephen Hawking was not a geocentrist.
I wasn't saying that. I never said he was. I'm just talking about as an idea.
Okay, so
philosophically speaking, that's all I'm saying. I don't know what he thought. I'm pretty sure he probably wasn't the geocentrist.
He certainly was not.
I'm sure he wasn't. It doesn't matter. It's a philosophical thing. It does not matter if he was.
So here's what
I've got plenty of other physicists who are.
Okay.
It's not a philosophically untenable position. It's a philosophical thing.
Okay.
It's a worldview. It's not right or wrong. You can't prove it either way.
Okay, so why would you even bring it up? But let's go down that though. When looking at the positions of things within the universe, you have to pick a reference frame.
Okay.
Right?
You can pick whatever reference you want.
When you're doing surveying work, they pick an ECEF reference frame. That's Earth-centered, Earth-fixed reference frame.
Okay.
So what they position the origin of their coordinate system at the center of the Earth, and have and assume then that the reference frame for the Earth is not rotating. Now that is again an assumption that's not true. But for positioning things on the surface of the Earth, it makes it much more convenient to use a coordinate system that is stationary in relation to the surface of the Earth than constantly moving in relation to the surface of the Earth. That's why they do it. So they use that coordinate system where one axis is the axis of rotation of the Earth, and the other two axes are actually rotating with the Earth. So now that's one reference frame. In that reference frame, a geocentrist would be quite pleased. They would say that is the absolute reference frame of the universe. Now, other reference frames can place the origin point at the center of the sun. Right? That's generally called heliocentric. Now, that is not actually the currently used model for the most cases. Most cases is a barycentric model where the origin of the universe is a point that's the barycenter, not the universe, of the solar system, is the barycenter of the solar system, which is offset from the center of the sun. And when you do that, the sun actually wobbles around it. Again, that's just another reference frame. So when you're talking about, when Stephen Hawking was talking about that, or I imagine the other guy, I didn't write down his name. They're just talking about reference frames, and you can do that. You can pick any reference frame.
Right. Well, that was my point.
But there are ways
go ahead.
There are ways to determine whether or not that reference frame is accurate. Velocity and acceleration are relative, but rotation is not. And you can measure absolute rotation. So you can place a rotation measuring device on the surface of the Earth and see if it rotates. And if it rotates, then you know that an ECEF coordinate system is not accurate because the Earth rotates. But you use it because it has a purpose. Right? So none of that, in fact, suggests that the Earth is flat. Right?
Well, that's your opinion. That's not my opinion.
I'll say it's the opinion of the people you quoted. How about that?
Oh yeah, sure. That's fine. I don't.
So
you guys have this thing where like a scientist has to agree with everything I believe, and that's not true. I'm using the name to back up a particular point. They don't have to agree with everything I believe. I'm not saying that.
It is.
That's a point y'all make a requirement.
There's a name for that though. It's called the fallacy of stolen concept. But that's fine. Okay, I've gone through your list. Do you?
Concept. I'm supporting what they supported. And Stephen Hawking, in his own word, is Copernicus did not prove Ptolemy wrong. That is not true in his own words. He said that.
Yeah, because you can use different reference frames.
Sure, I agree with that. Sure.
All right, so I presented a couple things.
All right.
Do you have any responses to that? I can remind you if you want. The sun could never set if the Earth was flat.
The sun could never set. Well, it is the flat Earth position that the whole sunset thing is simply a matter of perspective. So,
if we can calculate perspective, there's formulas for that. It's triangulation.
Yeah, but the horizon is not a physical thing.
It doesn't change the angular elevation of the sun. Has nothing to do with it.
The sun simply moves out of the range of the perspective of the person he's looking at.
How does that happen?
That's what sunset is.
Those are just buzzwords. Can you put some actual testable hypothesis behind that, please?
Well, we observe sunsets. You've seen sunsets, right?
Yep, keep going. Okay. A testable hypothesis for going out of perspective. Let's. What do you got?
Okay, fine. Okay, well, I believe that the sunset is nothing more than the sun moving outside of the range of the observer.
Okay, and what is the distance at which it becomes no longer in the range?
Well, at sea level, the range of at sea level, the range is about 3.9 miles or 3 miles per thereabouts, about 3 miles.
So
at sea level. At sea level, it depends. If you change altitude, it could be further. Depends.
Okay, I have been on the ocean in Florida, which is significantly farther than 3.9 miles away from the Tropic of Capricorn, or Tropic of Cancer. Yet the sun was up. So how can I see the sun when it's more than 3.9 miles away? And you just said that's the limit of our ability to see the sun.
What was your altitude?
On the beach.
You were staying on the beach. The range is about 3 miles.
Okay, but the sun was up, and the sun was definitely farther than 3 miles away. How was I able to see it?
Where was it? I mean, like it was at sunset. You're saying? No,
midday.
Oh, midday. Okay. Well,
let me explain again.
But I mean,
Let me say. I want to review it. You said that
I'm talking about sunset.
You said at sea level, when the sun is more than 3.9 miles away, you should not be able to see it anymore.
I mean, at sunset. Yeah.
No. What is the distance at which the sun will appear to set over flat Earth?
It depends on the observer's altitude.
Okay, let's put them at sea level. What's the distance?
Okay, well, it'd be about 3.
Okay, so when the sun is more than 3.9 miles away from the observer,
it's obviously further than that. But I mean, it's
okay.
It's really
then how could the sun ever?
It moves away. Go ahead.
How could the sun ever appear to rise if it's always more than 3.9 miles away from the observer in Florida?
Well, the horizon is not a physical thing.
It has nothing to do with it.
Nothing more than a limitation of the observer.
So your horizon
depends on or your apparent horizon, in this case, your apparent horizon it depends on your altitude and atmospheric conditions.
Okay. So I'll do this is as a teacher. I'd expect, even though you're not a math teacher, I'd expect that you could handle 8th grade math, right?
All right, go ahead.
I want to know, Ken, do you think you should be able to handle 8th grade math?
I'm not a math teacher.
But
you want to know about
if you want
to know about grammar and
okay,
how to categorize and how to categorize a sentence and parts of the sentence, I can help you.
Okay, did you successfully complete high school in the United States?
Of course I did. I completed college. I completed certification.
So in 8th grade,
mm-hmm.
and probably again in about 10th grade, you would have covered
mm-hmm.
the geometry I'm about to show here. So here I have
mm-hmm.
the flat Earth from the side, and we have our little observer here, right? Right. Now let's put the sun up here. This is not to scale. We don't really have a to scale because paper's not going to do the measurements on here. But all right, so there's the sun. Let's say this is the closest that the sun ever gets to that observer on that particular day, right? So that let's do it. Let's have this be the solstice.
What's the altitude? What's the altitude of the sun?
Well, that's a great question. We can actually calculate this ourselves, but let's say right here we've got the Tropic of Capricorn, or sorry, Tropic of Cancer. I keep saying, and the equator, and the Tropic of Capricorn, right? So here it's circling around. It's going to go around this way, right? But I can draw it on a AE map. We can measure this angle to the sun, and we know the distance from any point to the Tropic of Cancer. So we can get the elevation of the sun.
Yeah.
It's going to be it's typically between 3,000 and 4,000 miles elevation. The problem is, of course, everybody gets a different measurement based on their latitude, which is a huge problem for you, but we'll ignore that for now. So here is the AE map. You know this, right?
Oh, yes. Very familiar.
So I will put my position in Minneapolis right here. And then I will put the Tropic of, right there. So here it is, midday. So it's hard to see, but my position there is in Minneapolis. And then you've got the Tropic of Cancer there with the sun. That's at the closest it'll ever get. And you can measure that. You'll get about 3,000 miles, let's say, roughly. Okay. Now, 12 hours later, where's the sun?
Are you asking me?
Yeah.
Where was it again?
Well, it's on the day of the solstice. So it's June 22nd or 21st, right?
Yeah.
So here's Tropic of Capricorn here. It's gone all the way around over to the other side here. See that?
Yeah.
Okay. So we can get the distance from there. I'm 45 degrees from the North Pole, 69 miles per degree, and then another 65 degrees to the Tropic of Cancer, right? So we can do the math on that, right? And what'll happen is we'll get another triangle, right? I'll do this. And that triangle, we can calculate the angular elevation of that triangle. See, none of this has anything to do with the horizon. It's according to just basic geometry that you definitely went through when you were in school. Here's the position of the sun at midnight. Oh, you turned off your camera there. There you go. There's the position right there of the sun at midnight. 12 hours opposite from this, right? 12 hours later. That angle there, we can get this angle, right? Theta. That theta angle is always positive, and in fact, from the southernmost tip of South America, on the their solstice, which is in December, It can never be lower than 9.5 degrees above true level. So it can never get closer than 9.5 degrees from the horizon. So it has nothing to do with the horizon. It can never get close to the horizon. This is for flat Earth. I'm testing flat Earth. I'm just doing the geometry that any high school student will have gone through. So,
but the horizon is not a physical thing.
It has nothing. It has nothing to do with the horizon.
The observer is looking.
But it has nothing to do with the horizon because the sun could never even get close to the horizon. It would always be significantly above the horizon.
It depends. It depends on where the observer is standing on the plane.
Exactly, and we can do the math. It's easy. It's covered in middle school and high school for people in the United States.
Yeah. Okay.
So
yeah, I would be aware. How
does this work for flat Earth? If you're saying this is not right, then what is the rightness for the flat Earth? What causes the sun to appear to go down? Because this is an application of perspective. And what is the
sun to go down? It's moving out of the perspective of the observer. That's what happened.
But we just tested perspective, and it could never go out of the perspective of the observer. There's never anything in the way. Darryl, there's never anything in the way.
There is something in the way. There is something.
What's in the way?
The horizon.
No, the horizon is down here. On flat Earth, the ground is down here. There's nothing blocking the view. If there's nothing between you and an object, you will see it.
It depends on how high it is. Yeah, if the sun is high, you will see it. You brought this up when you were talking about when you were in Florida. It was noon, you said, right?
Yeah.
You said it was noon, right? Because it was noon, so it was above your head. But as it continues west throughout the day, it will draw closer and closer to your apparent horizon.
Yeah, but like I said,
and so it moves out of the perspective of the observer.
But Darryl, I did the math.
So that's when the sun apparently disappears. It does not disappear. It simply goes outside of your view.
But Darryl, I applied perspective. We can do the math for perspective. This angle theta never gets negative. It would never get close to the horizon. So why would it get obstructed?
Not a real thing. It's not physical.
It doesn't matter. It would never even get close enough.
It would.
So what is
what happens.
But what is the testable hypothesis that we can use to confirm whether or not your idea is correct?
Okay. All right. Okay. Good. Okay. Good question. All right. Well, okay. Have you traveled much? Have you been around much?
Sure.
All right. Ever been to Dubai?
No.
Okay. Well, there's the Burj Khalifa Tower, for example. That's a good example. It's a well-known phenomenon that you can see the sunset twice at the Burj Khalifa. All right. Okay. So you can stand at the bottom or on one of the levels of the Burj Khalifa tower, and you can see the sunset go down once. Right. Okay. So you can see the sun. So you can watch the sunset at the bottom of the Burj Khalifa tower. You go up, and you can watch it again. You change altitude, and you can watch the sunset again. That is evidence that the sun is moving away from you.
So when you're the same distance from the sun, you can see it again.
You're not the same. Well, I mean,
because it's moving away from you. That doesn't really make sense. I don't think.
No,
it's the same distance from you, or very near the same distance from you.
Moving away from you. So it's changing distance from. It's moving away.
Yeah, and what is the math behind that so that we can test your hypothesis?
I'm just talking about what we see.
Now I'm asking you for a testable hypothesis.
I'm not the math guy. You're the engineer. I'm not.
I already did it, and it doesn't work.
Well, it does work. If you take, you can take a drone. You can take a drone and do the exact same thing.
All that you've done is state. All you've done is state observations. You've not explained how it works on flat Earth. So far, Darryl, let me explain this. You have said you have presumed the Earth to be flat. and then identified something.
Are you opposed to doing an experiment? You're the math guy. You can do the equations and little numbers. No, that's fine. I'm asking. Have you done an experiment?
Sure.
Let's try that. Okay, yes. Great. Well, you can replicate the exact same experiment using a drone. You can go out and do the exact same thing. You make the drone go up a couple 100 feet. You'll see the sun go away. You raise the drone 50 feet. You'll see the sun. You'll see the sunset again.
Okay.
Just like the Burj Khalifa Tower. Same thing.
But Darryl,
that does not work on a ball.
Darryl,
turning away from the sun.
Darryl, as you said, I'm the one that understands the math and geometry. That is predicted. That is predicted on a ball. It is not predicted over a flat surface. Over a flat surface. Over a flat surface, geometry predicts that since nothing is in the way, you will be able to see it. Right there.
You do have something in the way. You have the horizon.
No, the horizon is down here, not here. It doesn't. There's no mountain in the way.
As it moves away, it connects with the.
That's just buzzwords. That's just buzzwords.
It's the connection. It's the section. It's where the It's where the sky meets the earth.
Yeah.
The horizon.
Darryl, you're just repeating your YouTube Papa Flurf. That's all that they said. You don't understand it either. Your Papa Flurf.
Who's Papa Flurf?
I haven't determined who your Papa Flurf is yet.
I'm talking about what I've observed. I'm just explaining what I've seen.
Yeah. Your observation. Your observation presumes.
I mentioned the Burj Khalifa Tower. I'm talking about a drone.
Yeah. It presumes step one of your observation. Hold on, Darryl. Step one.
We're not talking about little numbers on the paper.
Darryl. Step one. Darryl.
Yes.
Step one of your observation is to presume the Earth is flat. You have not yet provided a plausible mechanism to explain why things get obstructed bottom up as they get farther away when there's nothing between you and the thing you're looking at.
Can you see infinitely far on the ball?
Yes.
No, you can't.
Well, if there's nothing blocking it.
You can see forever on the ball. Is that what you're telling me?
Yes. Photons travel and they get to your eyes.
Yes.
That's it.
How far is that?
As far as the photons traveled successfully. That's all it needs.
Okay.
There is no distance, no maximum distance to sight.
There's no maximum distance to sight. So there isn't fog, haze, horizon. None of that exists. We know that exists. You talk about it all the time.
So
the geometrical horizon nobody sees?
So let me get this clear. Yeah. Is the sun brighter or is the sun brighter than the stars?
The sun is brighter than the stars, yeah.
Okay. Are the stars closer or farther than the sun on flat Earth?
Well, I mean, the stars are further away, yes.
Okay, they're farther away and they're less bright.
Yeah.
Now, you probably know that directly above the horizon, unless there's some, clouds or fog or haze, but on many days, directly above the horizon, you can see the stars, which you've said are farther away and less bright than the sun. How is it that the brighter and nearer sun is blocked by whatever you think it's being blocked by in the air? Yeah. No, but you're saying it's fog and air particles in the thickness of the atmosphere.
No, I'm just saying there are obstacles in the way. There's the horizon and there's other atmospheric conditions.
But those atmospheric conditions don't block the stars.
No.
How could these
they can if there's clouds in the way, of course.
How could these atmospheric conditions block the sun but not block the stars?
No, I'm just saying that there are things in your way. Anyway,
okay, so when there are not things in the way, the sun is still blocked. What's causing it?
The horizon. The connection between the point where the ground and the heavens meet.
What is the plausible mechanism that causes the obstruction, even though there's nothing between you and the thing that you're viewing? What's the plausible mechanism for that?
The horizon.
Okay, that's not a
It's what's blocking
plausible.
it.
That's not a
The horizon is what's blocking
plausible
it.
mechanism. That's just a
You
buzzword.
have to be standing under. You have to be standing under the stars to see them. You do acknowledge that you can't see the southern hemisphere stars from the northern hemisphere.
Yes, because the curve of the Earth is blocking it. If the
No,
Earth
the
were
curve is
flat, there
That's
would be
assumption.
nothing blocking it, and geometry
No.
predicts that we would see it all. So you
No,
need to
that's not
provide. So, well, I know the geometry. You don't. So don't tell me that the geometry is not true. You don't know the geometry by your own admission. I can
Yeah.
by your own admission. So don't you tell me that my geometry is wrong. If you want to, feel free
It's
to
numbers.
present.
It's a mathematical model.
Feel free
I
to
know what I see.
present what's wrong with my geometry. Otherwise, don't tell me the geometry is wrong. The geometry predicts that the sun should always be visible and the stars in the southern hemisphere
it's not
should
always
always be
visible.
visible. Exactly. That doesn't work. So flat Earth predicts that we should see all these things and we don't see all these things. Therefore, the Earth is not flat.
No, the Earth is big. Okay. I get the problem. Okay. All right. Okay. How about the surface area of the Earth is bigger than you say it is? That's the problem. I get it now. The surface area is bigger than you're saying that it is because you think it's limited by a ball. It's not. The southern hemisphere is bigger than the northern hemisphere. The Earth is bigger. The surface area of the Earth is bigger than people believe that it is because the ball is a limitation. Well, we don't believe in this supposed limitation.
Right. So you have.
We believe the surface area of the Earth is bigger. That's the problem.
You have measurements of that then?
No, I don't have measurements.
Okay. So why would you make such a claim?
Because Neil deGrasse Tyson says it's pear-shaped. So the southern hemisphere is bigger than the northern hemisphere.
And
yes.
And according to Neil, by how much?
Oh, I don't know. It's chubbier on the bottom than it is on the top. That's all. So that's northern hemisphere versus southern hemisphere.
Very, very tiny amount.
You would say small, yes, of course.
Yeah. So that's according to Neil. So if you're gonna quote Neil, don't cherry pick and put words in his mouth that he doesn't mean. That's dishonest.
I didn't say all that. I know Neil deGrasse Tyson does not think the Earth is flat. I'm not saying that.
Okay.
I'm not saying Neil deGrasse Tyson thinks that the Earth is in the middle. I'm not saying that either.
Okay.
I'm agreeing with him on what we agree on. He does not have to agree with everything I believe. There's that prerequisite again. He doesn't have to agree with everything I believe. I'm not being dishonest by agreeing with him on what we agree on. That goes for Stephen Hawkins or anybody else you claim of being dishonest about. I agree with them on this point. They don't have to believe that the Earth is flat. They don't have to believe that the Earth is in the middle. They don't have to believe that. They, for philosophical reasons, have not chosen that particular worldview. That's fine. Doesn't make me dishonest for quoting.
All right.
Okay. So anyway, so the surface area of the Earth is bigger than we think it is. That's why there's this misunderstanding. There is a point where heaven and earth meet, and you cannot see beyond that point.
Okay, but
you have to be standing under the southern stars in order to see them.
Okay, but
and
you
by
still.
The way, yeah, as a world traveler, I would also like to say, look, I've been flying on airplanes as a passenger for over 20 years, and I have never observed any curvature of any kind.
Okay. Have you been? What's the highest? What's the highest you've been in an airplane?
As on a plane, it's commercial airline, so 30,000 feet.
Okay.
So the surface of the Earth, I have never observed it declining in any way whatsoever. The planes do not change pitch.
Okay.
That does not happen.
So where do you have any measurements of these things?
I have no measurements. I'm not.
Okay.
I'm like, you're the measurement. I'm like, you're the number guy.
So you made a quantitative claim about the horizon dip, right? You said that.
When I said it was a dip. When I say dip. When I say that.
Well, I'm using that word because that's the common word.
I didn't say horizon dip. I didn't say that. You're putting words in my mouth.
Okay, so rephrase what you said about that then.
I never said anything about a dip.
Okay, but as you get higher in elevation, what were you expecting to see out the airplane window then?
I've been at varying altitudes in the airplane. In the airplane, I've never seen any declination or curvature of the Earth whatsoever.
Okay, so declination.
I've never seen no curvature. I've never seen any.
Okay, just a second. Then let's go back. So declination, dip. That's what. Okay.
Declination. Okay. Never seen it. I have not seen it. Haven't seen it dip.
And how did you measure the quantity of the dip or not dip or declination? How did you measure that?
It was 0.
How did you measure that?
With my eyes. I sighted.
Okay. And what's the margin of error of your eyes? And as far as measuring angles? I did not perceive
it dip.
Okay.
I did not perceive any declination or any change.
Okay. But so what's the margin of error of your eyes?
I did not perceive a change in angle.
Okay. So, but you don't. But my question is,
the Earth is a flat horizontal plane as far as I can perceive.
What is the limit of your eye's ability to perceive? Is your eye able to measure a 1 degree dip of the horizon without any external reference? Are you able to do that? The answer is no.
As that change would compound, because it wouldn't stay at one degree. It would change. The altitude of the plane does not adjust.
But Darryl,
it flies perpendicular to the flat plane.
Darryl, answer the question. Is your eye able to measure a 1 degree dip of something without an external reference? The answer is no, Darryl. Your eye cannot. Without an external reference, you cannot. In fact,
fine. So, let's say the answer is no.
Okay.
I still have not perceived any change in declination whatsoever.
As predicted on the globe. So what you're doing here is
so there's some trick of aerodynamics that I don't understand. Is that what you're telling me?
No, you are suggesting
you're telling me it's a ball, but it doesn't. But the plane doesn't have to keep up with the ball.
Let me finish.
That's the argument you'll make.
Darryl. Darryl, just let me explain this. When you phrase it that way, you are suggesting that if the Earth is a sphere, you should see a declination of the horizon. Is that what you expect? Okay. How much at 35,000 feet? How much angular declination should there be?
You're telling me that there's a ball. I don't see it.
I'm asking you. Here's the deal.
I'm being gaslighted here. We perceive no ball.
You have declared that you did a test. Okay. Mm-hmm. And I'm just going over the details of the test because that's what we do in science. We want to be detailed about our test. So how much should, with the Earth's measurements that we've identified, about 4,000 mile radius, how much dip should there be to the horizon at 35,000 feet? Do you know that?
There is no dip.
Okay. That's not the question. You're deflecting from the actual. You're deflecting.
I don't believe it's a ball.
This is how you test a hypothesis. We're going through a hypothesis test. There's
no change in pitch.
Listen, Darryl. You don't test a hypothesis by repeating religious mantra. So let's drop the religious mantra and test your hypothesis.
Religious mantra is telling me that there's a ball there that nobody sees.
We're going through Darryl.
That's what I'm saying.
Let's test your hypothesis. You're being extremely resistive to this.
Go ahead.
So please stop being so resistive to this. This is how you do science. You get a hypothesis. You calculate the ramifications of that hypothesis, and then you compare it to observations. If those observations don't match, then the hypothesis is wrong. Okay? If the observations do match, the hypothesis might be right. Okay? Not necessarily, not absolutely, might be right. Okay? That's all we get in science is the hypothesis might be right, or the hypothesis is supported. So at 35,000 feet, with a radius of slightly less than 4,000 miles. We expect an angular dip of 3.2 degrees. Our eyes, without an external reference, cannot identify a 3.2 degree vertical change. We need an external reference. You have to measure that. You did not measure that. So your observation is inconclusive. No problem with it. But you need to understand it's inconclusive because you were not able to, within the margin of error of your measuring device, which is your eyes, you were not able to identify if there was enough dip or not.
Yeah.
Okay. Same thing. We can, all your other measurements that you talked about, we can go through all of them, but let's stick to just the dip for the moment. Okay.
Okay. Yeah. Okay.
So I have done that, and you can, when you're on a plane the next time, you can install the Theodolite app. Okay? The Theodolite app uses your phone's accelerometer to identify eye level. Right?
Okay.
And my phone is accurate to 0.01 degrees. The Theodolite app I use is accurate, only reports 0.1 degree. So it's not as accurate as the phone is, but you're not losing, you're not going beyond the precision of the device. So I flew from Anchorage to Minneapolis 2 years ago.
Okay.
And at night I looked out the window and there were some clouds, but the moon was also visible. So when I was there, I took a picture using the Theodolite app of the moon, right? With the horizon, or sorry, the horizontal line. So the horizontal line is at eye level. Okay, so anything below that is dipping. Anything above that is elevating. So here's the picture that I took. You see that crosshair there? That horizontal line is eye level. Everything below that is lower than eye level. The entirety of the moon is below eye level. And then down below the actual square, you can see there's clouds. So those clouds are much more than the moon in declination. So I actually tested the thing that you did. I tested with a measurement. So the entirety of the moon is below eye level. So, in fact, confirmed that there is declination when you're in an airplane. Now this isn't the only one. Here's another one. Somebody else using a Theodolite app. Right here from Globular Epic Bikini. He did the same thing. It's the exact same app. The cool thing is the latitude, longitude are listed in here. So we can see in the elevation. This is at 11,000 meters, and you can see again, he's dipped it down. You can see is it yellow or green there? The box. I'm colorblind. I don't know if it's yellow or green. That's eye level, and then that bar, that crosshair down farther, that's at 3.3 degrees dip, as predicted on the globe with a radius of 4,000 miles. So it confirms the hypothesis. But that's not the only one. Here's another one from D. Wolfman 54.
Oh yeah, D. Wolfman. Yeah.
I don't know who D. Wolfman is, other than he had.
I've heard the name.
Maybe you've heard Wolfie 6020.
Or maybe Wolfie, yeah, okay.
Yeah. So here it is. He did the similar thing that I did. The crosshairs are he's actually at negative 0.1 degree, and the horizon is significantly below that. And he's at 33,000 feet. So we tested the hypothesis that if the Earth is spherical, the horizon must dip with increasing elevation. And we confirmed that it does, in fact. So we can conclude that the hypothesis is still possibly true. But now we can do the same thing for flat Earth, because if the Earth is flat, then geometry demands that the dip will be either zero if there is an infinite plane, or it will be very, very small if there's some ice wall around Antarctica. So small that at the distances that people are in the northern hemisphere, it would be smaller than the margin of error of measurement. All three of those pictures showed that the horizon did not rise to eye level. Therefore, the hypothesis that the Earth is flat is falsified.
I would disagree with that, but go ahead.
Well, what was wrong with the methodology?
I don't perceive the ball you tell me should be there. That's all I'm saying.
Okay, but I wasn't talking about that. I was talking about the hypothesis that the Earth is flat.
That there's an ice wall, or what? Which one falls?
And that either there's an ice wall or there's an infinite plane. Maybe you have a different idea, and you could correct me on that. But both of those, when you do the math, the horizon must rise to eye level within the margin of error of the instrument. So less than 0.1 degree dip. Yet all three of those examples had much more than 0.1 degree dip. Therefore, it doesn't match the hypothesis.
Have you ever stood at the end of a hallway?
I'm sorry, don't change the topic. Unless you want to concede this.
I'm just talking about perspective.
Yeah. And I can do the math for perspective.
Okay, right. So at the end of the hallway, the floor and the ceiling come together at the end of the hallway. Does that mean that the area beyond the hallway disappeared?
Nope.
No, right. Because you can't see it. Right?
Yeah, with a better optical device, you can resolve more detail.
Yes, exactly. Okay. All right. So, that's why we don't see for an infinite amount of time. But even in a hallway that might be several meters long, we can't see what's beyond that. Well, same thing happens on the Earth. Okay. On the flat plane. Right? Okay.
But
okay. All right.
But the perspective of that.
So his perspective
is that the bottom of the hallway rises up to eye level and the top rises or drops down to eye level.
Yes.
Right.
Yeah. Yes.
And therefore, then we can extend that to the hypothesized flat Earth, that the floor of the flat Earth, that's the ocean and the dirt when you're at high elevation, will rise up to eye level, not any higher,
exactly.
Never any higher, and the top will go down, never any lower. So if you have lights on the ceiling, those lights on the ceiling will never appear below the floor, right?
Yeah,
and
sure.
They will never get obstructed by the floor. They will simply get too small to see. And if you get a better optical device, you can resolve more detail, and they will not be obstructed still with larger, right? So when we do that,
I would disagree with that. If you move back far enough, there is a point where even you wouldn't see the ceiling anymore, the light in the ceiling also.
And what causes that? What's the plausible mechanism that causes that?
The ground rises up.
Okay, but
the further you go back, at least it appears to rise up.
What's the plausible mechanism? What's the plausible mechanism that causes the ground to obstruct the ceiling?
Perspective.
No, perspective is just uniform reduction in angular size with increasing distance. That's all that perspective is. Things get smaller. That's perspective.
Yeah,
they don't get
as long as you're on the same plane of vision. Yes,
they don't get things always get smaller with increased distance. That's perspective.
Not always.
Not always. What is the exception to the rule that things with increasing distance don't get smaller?
The sun.
So presuming that
the sun does not change size.
But that requires you to presume that the Earth is flat in order for you to say that.
Yeah, it is.
Okay. Well, you don't get to presume the Earth is flat while you're claiming the Earth is flat and trying to test to see if the Earth is flat. You need to have that be the outcome, not the pre-selected conclusion.
My life experience tells me that the Earth is flat and does not move.
Okay, so
I can only go from my observations and my experience. Call that religious belief. It's not. It's my observation.
Darryl, none of this makes any logical sense, though. That's the problem.
I keep telling you, it's all perspective. You know.
But you don't know how to calculate perspective.
Well, you keep talking about the calculations. I mean, I know what I see. I have not seen a declination in the Earth at all.
But I just showed you the declination.
Moving forward in time and space.
I just showed you.
This is my problem. No,
all you've done is deny.
Hold on. Listen. Hold on. This is my time to talk. Okay, right. You've been talking nonstop. I've been polite.
Go ahead.
Okay, now look. Okay, so according to you, the Earth is a ball. That is your belief, right? Okay, so if I'm in an airplane moving forward in time and space on a ball, if the plane is moving forward in time and space, the Earth should decline. It should drop away from you. I've never seen that. I can move, according to you, I can be on the ball. I can move forward in time and space for a 12-hour flight and never detect a declination, but it's still a ball. All right, that doesn't make logical sense to me. You want to talk about logical sense? You're telling me that there's still a ball there, even though I don't perceive it. That's my problem with this. You're telling me that there is a geometrical horizon that cannot be seen, cannot be measured, cannot be experienced, but it's still there. You assure me that it's there. That sounds like a religious belief to me. That sounds like faith. Just saying. That's what it sounds like to me. I'm not the numbers guy, but I'm just talking about my own experience. I'm a bit defensive because you're telling me, oh, well, I'm not seeing what I'm seeing. That's why I'm defensive.
Okay.
You're telling me there's a ball there that I don't perceive.
Yeah, and I would say that your perceptions aren't finely tuned enough to see them. But we do have...
So there's a ball there, but I can't see it.
Absolutely. And we do have measurement devices that are able to be precise enough to do that. And I showed them to you.
Trust the numbers and trust the devices. Okay, I got you.
That's how you explore the universe. It's how we find out things. We don't measure a 2x4 by just looking at it. You use a ruler. You don't measure the angle.
If you want to know the exact numbers, that's fine. I got that. There's a place for numbers. That's fine. I do have a respect for that. There's a time and a place for it. Yeah, but you can also eyeball things.
Science is where we use those things. In science.
Yeah, I got you. I got you. But I see what I see. And I experience what I experience. I don't perceive a ball in my experience. I don't perceive any emotion in my experience.
Yep. Even though we can measure it. Okay. Do you mind if we got some questions from the audience?
Okay. How long have we been going now?
We're at an hour and a half. So whatever you're good with.
All right. Go for it.
Be good to finish within the next 30 minutes. Alyssum says, good morning, stay hydrated. Hope everyone has a good day. He's in Australia, so it's good morning for him. And now for tradition, Darryl, why is all navigation based on a globe?
All navigation. Is it based on a globe? I wouldn't say that that's the case.
Oh, well, when is navigation not based on a globe?
Let's see. We use there's a particular map that we use. It's not a globe.
Which map is that?
I forget the name of the map. But anyway, people are not using a globe to plot a flight path.
Sure they are.
Pilots do not use a globe.
That's completely wrong. Do you see on my wall behind me here?
They're not using a globe. They're not using a ball when they plot a flight path. That's not what they're doing.
Do you see it on a flat piece of paper. Do you see this piece of paper behind me?
It's a flat piece of paper. Yes.
Hanging on the wall.
They're not using a globe.
Yeah, these are Lambert conformal conic projections. They are based on a globe. So the question is, why is all navigation based on a globe? Those maps are based on a globe. Why are all navigation based on a globe?
Well, you're telling me it's based on a globe. It's not clear to me that it is. They use, because sailors, I know they use I can't think of the name of the map.
They use a Mercator projection for sailing.
Okay,
Both of them are
but
based on a globe.
it's still applied. It's still applied on a flat piece of paper. It's not a globe.
Absolutely. And it's based on a globe. So why is all navigation based on a globe?
No, it's not based on a globe. It's on a flat piece of paper. All maps are flat.
But
no one's using a globe.
But all navigators disagree with you. They do things based on a globe. So, all right. MC Toon's cat is saying, meow, I'd like some tuna, please.
Okay. Feed your cat.
And then Alyssa sent a donation for tuna. So funny to bring that up there. That's actually Microraptor, not MC Toon's cat. My daughter, her friend down the street, their cat had kittens, and they're like, would you like to have one of our kittens? I'm like, no. Yeah. But my wife, it's for my wife who's allergic a little bit. She's like, I think maybe we should. So 2 days in a row, I'm like, we could borrow the cat overnight just to see.
Yeah.
I'm going to keep going there. Anyway, so we've got a new cat in the house.
So, okay, congratulations.
Our previous cat, we still have it, is a cat named Raccoon, and our new cat is a cat named, well, guess in chat. What do you think is the new name for the cat? 3Ron says, argument from antiquity and credulity wrapped up. Now, when you mentioned the ancient
cosmology, I get it.
Yep. All right. I love this question. I've never seen such behavior in the war room before, asks. Hey, Darryl, what's the cause of the two celestial poles according to the globe?
According to the globe?
Yeah, according to the globe, what's the cause of the two celestial poles?
According to the globe, that'd be, what is that? The magnetic field?
No, not the magnetic pole, the celestial pole.
The celestial pole.
Yeah.
You mean Polaris and what is that?
Sigma Octantis? Yeah,
Sigma Octantis.
Yeah, neither of them are actually at the center of rotation. The center of rotation is the celestial pole. There is no bright star in either north or south. So what's the cause of the center of rotation?
You mean why is it spinning?
No, what's the cause of the two celestial poles for the globe?
The celestial poles on the globe.
Yeah, why do we see two opposite rotating star trails when we do long exposure photography?
On the globe?
Yes.
Well, on the globe, y'all would say it's the Earth's rotation.
Yes.
Yeah, that's what you would say. I would disagree.
Yep. And then the plausible mechanism for a southern celestial pole on flat Earth is what?
On flat Earth, okay. Okay, well, for the northern pole, Polaris, all stars move around Polaris counterclockwise. There is a 15-degree shift, a 15-degree rotation every
about
20 minutes. Yeah, something like that, right? Okay. And then the southern on flat Earth, that's caused by, what is that? That would be a reverse. I would say it would be a reversal of the southern magnetic field, which causes it to spin in the opposite direction. That's what we observe.
The magnetic field causes
the change of polarity.
That's a new one.
That's
a new one. So
it's probably my theory. I think so.
Yeah. Well, let me give you a couple things here, so maybe you can amend it in the future. Magnetism does not affect light. Light is the messenger particle for electromagnetism, so it doesn't affect itself. It has no charge. So light can go through a magnetic field, a changing magnetic field, and it doesn't change its direction or bend. There's the two main mechanisms for that would be refraction and gravity. So anyway, so there you go.
I would like to add one more thing since we're talking about it. Then I would say that would not be the case if there is a medium. I believe that the ether is the thing. So
okay,
I would say that would make a difference. But I just wanted to say that. Go ahead.
But Michaels and Morley concluded there's no ether. So all right.
No. They did get a slight positive result.
Yeah, I've read it. They concluded there's no ether. And are you aware
that wasn't the conclusion. The conclusion was that they did get a slight positive result. They detected 1/6. They detected 1/6 ether. They did detect something.
Ether.
They did detect something. And by the way, don't forget about Dayton Miller. Don't forget about him. He detected a whole lot of ether.
Yeah, I've read that.
He did detect a whole lot of ether after his interferometer experiments over 20 years. So he did detect something.
Yeah. Now,
and Michelson Tesla also believed in it as well as
but Michelson Morley Tesla doesn't have any experiments to cite, so that doesn't do us much good. It's just a guy thought that.
Well, Dayton Miller did over 20 years.
Yeah.
He also had control.
So Michelson Morley has been redone many, many times with significantly tighter margins of error, and the amount of error that they had in the original Michelson Morley has been completely obliterated with the
I know. There was another replication of their experiment around 2009, I think. I think you'll find it's rare that it didn't happen at least once in every year since Michelson Morley. Okay. So it's been redone many times. But anyway, I'm bringing up Dayton Miller. I'm throwing that one out there.
All right. Alyssum says he always has been wanting one of those rigid aircraft. So, all right. Elabaka says, Darryl, planes are not rigid nor do they have constant mass. Why would a flat, non-rotating Earth be a fact then? These are all assumptions based in reality. Kind of went over that, didn't we?
We went over that. It's the same question.
Yep. All right. Dave Rogers says, if the Earth were actually flat, what would be the point in clarifying it in any paper, model, design, etc.? Like for the those derivation of linear aircraft. Well, why would they mention it if the Earth were flat and non-rotating? Why wouldn't they just say not paying any attention at all?
I would ask the opposite question. Why do you mention if it's not true? I still don't understand that.
Because they were specifically instructed not to do it.
I got you.
Yeah.
I got you. Yeah.
All right,
we've got. Make sense to me, but anyway, go ahead.
Oh my goodness, this Polish name.
I will look at your paper. That's interesting.
Przemek. Przemek. I'm sorry, it's going to be wrong. And then the last name has a cedilla on an E. I don't know how to pronounce that. Swisicki, maybe. It says, greetings from Poland, MC2, and love listening to your FE debates during work. You are a savage. I'm sorry I pronounced your name wrong. Thank you for that. And then he says again, ancient civilizations also believed that bloodletting heals people. Why should I care if they also believed in flat Earth? The world has moved on.
Well, that doesn't mean you have to agree with everything. That's my whole point.
So you can cherry pick.
You don't have to agree with absolutely everything. I'm not saying they were perfect and everything. We have to agree with everything. They were wrong about some stuff.
Yeah.
But I do not believe they were wrong about flat Earth. I'm not saying they were perfect.
Cherry picking is item number 3. Okay.
Well, it's just like the scientists who we can align on a particular point. That doesn't mean I have to agree with everything they believe.
Yeah.
I don't think that's a valid point.
Yeah, it's just
cherry.
There's a name for it. It's called cherry picking.
I
but that's
believe
okay.
there's something called do not throw the baby out with the bathwater. I think it's an extreme position. That's all. I think it's an extreme position.
Okay.
No one has to agree with everything I think. I don't have to agree with everything they believe. That doesn't invalidate everything they believe.
Yeah, you're right. You're right. All right.
That doesn't invalidate everything I believe because they don't agree with everything I say. I think that's a fallacy.
Okay. Cygnus Step says, still waiting for Mick Toon's report on the Megadeth show. I love Dave Mustaine. He grew up in a JW house like I did and overcame. I didn't know he was a JW. It was a fantastic show. I got there just as the previous opener band was doing their last song. So I do like me some Megadeth. It was a little shorter than I would have liked. I would have liked 4 hours.
No, you're a fan. Okay.
Gregorio Gagnon says, as a fellow English teacher, I am concerned that you will not read a full document to understand what it says. Where did you go to school, Darryl? Don't dox yourself or anything you don't want to share.
It's okay. I don't mind. I don't mind telling people. I work very hard for my qualifications. Yeah, I went to school in Maryland, PG Community College. Got my AA there, and then I got a double BA in Latin American Studies and Spanish Language at Towson University in near Baltimore. And then I also got a TEFL certificate in Prague, and then a CELTA certificate from Cambridge, also at Washington, D.C.
There you go. Gregorio. Stanji says, why does the sun and moon disappear bottom up? Does the bottom get too far for us to see seconds before the top? Wouldn't the bottom be closer to us? If it's because
we went over this before. The sun, as far as the sun is concerned, the sun is moving out of our perspective. For the moon, it would be similar.
But the bottom of the moon is closer than the top of the moon. Wouldn't the bottom of the moon be the last part to go since it's closer?
What do you mean? What do you mean when the moon sets? You mean the phases?
No, it's the set. Why is it obstructed bottom up? If it's going farther away, as you say, the bottom of the moon is closer than the top of the moon. The top would be the farthest away and should be the one, by that measure, should be the first part to get obstructed, not the bottom.
No, the bottom. Yeah.
But
because
why?
It's moving out of your perspective.
But why the bottom first? The closest
part.
part.
First, because the ground is because of the horizon. The ground is blocking the bottom as the moon or the sun moves away from you.
Yeah. All right. Well,
I've actually seen this.
Yep.
I've actually watched it.
Yep.
You sit there and you watch the moon, it moves away from you like this. And it moves away from the observer. That's what happened. I've actually watched the mountains. I've actually watched the moon move toward the mountains and actually disappear behind the mountains. Bottom to the top first. The bottom first. I've actually watched it.
True, and that completely matches the globe.
I don't understand why that's a strange question. It's not.
And has no plausible mechanism on flat Earth. So maybe try to figure out what the plausible mechanism is.
I can tell you it's simply moving away from the perspective.
But that's not a plausible. That's not a plausible mechanism.
Just like the hallway.
Again, that's not a plausible mechanism. That's just buzzwords.
It's what I observed. It's what I observed.
All right. Tim Tully asks, Darryl, have you ever had a conversation about these subjects with a physics or earth science teacher at your school?
No, of course not. No.
Maybe you should.
No, you think I'd be running around talking about flat Earth? No, I might get fired. I don't want to do that. I need my job.
All right.
These are potentially volatile things. No, I don't run around discussing them with other people. Just people that I know might be sympathetic to.
All right. So Jolene is wondering, Darryl, if the Earth was flat, why the big lie about it being a globe? What would be the point?
There's an old Egyptian saying. Those who know rule those who don't. If the control of information is power, my question is, why do you think your rules would tell you the truth? They want to have more information than you, so it's logical for them to hide at least some information from you. Why would they tell you the truth?
But how does that benefit them?
I don't know. I'm not the one who's lying. You ask them. It's control. It's a method of control.
For 2,500 years. All right. Indy Tiger says, Darryl, does the horizon exist or not? You claim there is no horizon when it doesn't work for you, and claim there is a horizon when you need it to.
There's always a horizon. The horizon is an optical effect. It's not a physical thing.
Okay. There you go. Indy Tiger says, again, Darryl, I navigated ships in the Navy. Ships on the open ocean make predicted course changes to follow the curve of the Earth, and all charts are based on a globe, even the AE chart.
Okay.
So that is a person firsthand experience, if we're to believe him, right? And I don't know Indy Tiger any more than you do, personally, but it is a common thing, and you can look at their charts and maps.
Sure.
And they all say projection. Even Gleason's map says it's a projection.
Okay. And my question to the sailor is, was not the ocean flat as you were sailing on it?
Yep. All right.
That would be my question to the sailors. Because I've been on boats before, and I have no idea why a sailor would come back talking about it's a ball after seeing the same ocean for 20 or 30 years. That's not the ocean I've seen. It does not stick to a ball.
Again, it's because the geometry makes sense.
That's numbers again. That's not what you perceive. You perceive a flat ocean.
I get that you don't do the numbers. All right. Alan Bupre says, Darryl, it's okay to admit you're wrong. It means you've learned something.
Oh yeah, sure. I'm wrong all the time. I get it. But I do not believe I'm wrong about the shape of the Earth.
So you don't think there's any possibility that you could be wrong about this?
Nope. I'm absolutely certain. I've never been sure about anything in my life. The Earth is flat and does not move.
Was it Dubé? 200 proofs? Was that your introduction?
That wasn't an introduction. I looked at several.
What was your... you watched all 200, didn't you? Right?
The whole Eric Dubé 200 proofs video? No, I did not.
You didn't?
I watched the whole thing, no.
You didn't? Okay.
No, I didn't watch the whole thing, no.
Okay. Who
By the way, I don't believe that the Earth is flat just because I watched Eric Dubé. That's not true.
Okay. Who do you watch the most?
As I've been saying, my experience in my life tells me I don't experience the Earth as a spinning ball.
Okay.
It's got nothing to do with Dubé.
And who do you watch the most?
He was part of my awakening. I'll be honest about that. Sure. That was part of it. But that's not the whole reason. Other people were part of my awakening, my other research leads me to believe that is the case. I do not perceive the world as a spinning ball. I do not believe the sun is 93 million miles away. All that. I don't agree with the model.
Okay.
And I believe the Earth is at the center and does not move.
All right. Mr. Unite for the Children says this cow is small. That one is far away. Are you?
You got some weird people. You got some weird people in your chat.
Are you a Father Ted fan?
Who?
That's from Father Ted. It's a good TV show.
I don't watch television.
Written by Graham Linham, who also did the IT Crowd and Black Books.
Never heard of it.
I love Black Books too.
Never heard of it.
3 Ron says, my far better understood experience says it's round.
I disagree.
3 Ron. Good old 3 Ron. 3 Ron, you got to come on again. Mr. United for the Children says, out of curiosity, English teacher litmus test. Darryl, I have no idea on this. Who are Pyramus and Thisbe?
Power Missing Frisbee? No idea.
Okay. There you go, Mystery Knight.
What is that? What is that? You know? You don't know?
I don't know. He says it's a English teacher litmus test. Do you like Nathan Thompson? Are you a fan?
Is that a YouTuber? Is that a YouTuber?
Oh, he is not your Papa Flurf then. I didn't. Phil Black, I was guessing. I didn't think so. I wasn't getting Thompson. So, all right. Flat. Glober Mom.
I really know the name. I think I've only heard. I heard the name.
That's to your great benefit. He is a horrible person.
I think because I think I've heard the name because of your debates with Whitsitt. I think.
Okay. Yeah, Whitsitt and him used to go out. They used to be.
That's the only reason I know the name. Otherwise, I don't know who he is now.
All right. So is Whitsitt your Papa Flurf?
No.
No. Who's your Papa Flurf?
What you mean? What you mean? Like who taught me everything I know about flat Earth? No, I mean it's a whole lot of sources.
Who's at the top of the Flurf pyramid for you?
I don't follow anybody. I'm a very independent person.
The problem is that it's all the same. It's all the same buzzwords, but that's okay. That's okay.
I'm not a follower of anybody. This is not a religious thing for me. This is not a cult thing for me. I don't agree with any one person on everything.
All right.
I fight with other flat earthers all the time on stuff.
Oh.
Because most of them are Christians. I'm not.
All right.
Anyway, go ahead.
All right. So let's see. Glober Mom says flat pieces of paper do not mean flat Earth. Gotta say.
Look, to me, all that stuff is all about the numbers. I perceive a flat Earth and a flat ocean. So
all right.
I'm not familiar with all the processes. I'm not gonna pretend that I am. But I perceive a flat ocean, and I perceive a flat Earth.
All right.
So what these sailors are doing to perceive a ball, I don't know. Because the ocean's always flat whenever I see it. So I'm not going to argue with them.
All right. So Saeed Ahmed, he's a little harsh here. He says, when does Poe teaches English to his students, do they become illiterate? Saeed, shame on you.
Well, that's nasty. That's not very nice.
I agree. Saeed.
I've gotten very good at these.
Maybe
my students like me.
Maybe a little more subtle in your stuff, Saeed.
My students like me very much. No, thank you.
So Mr. Malort, and the O has umlauts over it, so heavy metal, confirmed. He says, as a teacher myself, this guy needs to have his credentials revoked. Ouch. He has no analytical skills, he says. All right. I think Mr. Malort and you should meet out behind the school after school and duke it out.
Yeah, those are fighting words. I think we should duke it out. He give me out back on the playground after school.
Oh my goodness. UKPL says cat called Nathan. No guilt when you kick it. I love cats. I just can't eat a whole one. All right. Warren Evans says, using flat Earth map, you explain how a person standing in Australia, South Africa, and South America all see the same stars looking due south. So that's a good question.
Okay, good question.
Here's the map, and I'll put them here. Due south.
Good question.
They all see the same thing.
Yes.
Now you're in Ghana. Is that are you south of the equator? You're real close, I think, right?
No. We're north.
Okay. So there it is. These three people looking opposite directions. Some days in June they would have nighttime simultaneously, potentially.
Mm-hmm. Yeah.
But otherwise, most days of the year, two of them will have simultaneous nighttime. So
yeah.
How do they all see the same stars?
Well, that's easy. First of all, the sun moves. The sun sets to the west, right? So they would not see
Stars.
the stars that
stars.
they would. Huh?
We're talking about the stars. Yeah.
Yeah. I'm talking about sunset, right? So they would not see the stars at the same time. First of all, but
Well,
as the sun
but they
sets,
do.
they in turn would see the same stars. It's not nighttime at the same time.
Yeah, but well, it is. There are days in June where all three of these simultaneously have night. But certainly the rest of the year, two locations have simultaneous night. The other thing is, from sundown to sunset, the celestial pole is in the same spot due south. It doesn't move like oh, the sun set here, it needs to be there, and then when the sun rises again it moves. It doesn't move. It's always there. So how is it that they can see the same thing when they look in these opposite directions?
You're telling me that would be night at the same time in all these three places?
Yeah, at least two of them at different times. Here, these two are not very far off, so they're going to have simultaneous nighttime. How can these two at least see the same thing when they look in those different directions? It doesn't make sense, does it?
Well, the stars move, so it's not.
Yeah, but they don't, right? This guy can look due south. This guy can look due south and see the crux, the Southern Cross. This guy at the same time can look this direction, which is about 90 degrees different,
and also see the Southern Cross.
And see the Southern Cross. How can that happen if they're in these two different spots looking in those two different directions?
I don't think that's possible. No.
I agree, yet they do. That is what happens. That is the reality.
Well, I don't know that.
Well, you don't need to know that. It is objective reality. You cannot just deny it. It is real, and your model, your understanding of the shape of the Earth must include. I don't care that you've experienced it. People have. There's 1 billion people that live south of the equator. They see it. They see it. You can't just pretend it doesn't exist. Denial is a religious claim, not a logical claim.
So, I'm not denying that.
It's not that they move simultaneously. They can simultaneously see the same thing, looking in opposite directions.
It would not look the same.
But it does look the same.
It would not look the same.
In reality, it does look the same.
It can't be in two places at once.
Exactly, they can't.
The sky does look different to people. People standing in different places. It would not look the same.
They see the same stars.
I'm not sure what it would look like.
That is an aggressive denialism. So we'll move on. Because Mr. Sensible.
I'll think about it, but it wouldn't look the same.
But it does.
Like same position and all that stuff.
Exactly. I agree. It would not look the same. You would not see the same stars, but they do. Therefore, the Earth cannot be flat. So anyway, Mr. Sensible, who has, remember the Dwayne Kellum thing where the balloon was up at a high elevation? Yes. Mr. Sensible, he has a channel on here. He did his own version of that same thing. He sent up a camera that's that doesn't have a big fisheye effect to it. Sure. And he says, I would love to debate Darryl about my Mage project. That's what he called it, Mage. Would you be interested in debating Mr. Sensible?
What's his Mage project? What is that?
That's what he called his balloon that he sent up to over 120,000 feet.
He wants to debate me on what?
Yeah, I think he would like to present his own personal observations. Oh, you don't have to decide. You don't have to decide now if you'd want to debate Mr. Sensible. But I could
talk
put
about
you in.
that later. I don't know that that's debatable. If he wants to share his information with me, that's a different thing.
All right.
If that's what he means, you can share your information with me. That's fine.
Yeah, he'd like to.
I don't think there's anything to debate. You either saw it or you didn't.
Yeah. All right. Well, Quitties the Sprinkler says, name the kitten Dave Meowstain. That would be
got some strange people in your chat.
that'd be the guitar player and the main guy from Megadeth. Do we have? Oh yeah, the MAGE stands for Mission Above Globe Earth. So let's see. Merp says, greetings from Gateshead. Finally caught you live to give you some tasty shill money. Looks like you've got another very, very expert here. Are you a very, very expert?
What's very, very?
Very. It's a joke. Which reminds me, I'm gonna have to.
No, get it. Sorry.
Gonna have to play something here.
Got some weird folks in your chat.
Yes, that's
lots of weird people in your chat.
You're correct. Oh, there it is. Okay, hold on a second. I'm gonna play. I'm gonna play a little something for people. So, I've done a couple music videos.
Were you singing?
No, not me. There are limits on freedom of speech, so you don't want me to sing. So all right, I'll give you guys just a little sample of the very, very expert.
I am an expert. I'm a weapon systems head-up display expert. And I'm a weapon systems expert.
No, you're not. All right. That's all you get. Just a little taste, people. Just a little taste. That song will be coming out within the week. Design song 1. I think we're getting to the end of these questions here. If a student told you that in his experience, Furker meant teacher, would you let him call you that and give him an A when he wrote with it?
It's not English.
Okay, but that's in his experience. Furker means
but
teacher.
It's not English.
Yeah, but it's the same thing as you did. In his experience, that means teacher. There is such thing as being wrong, right?
But it's not English.
Absolutely.
As an English teacher,
absolutely
it doesn't
agree.
need teacher in any language that I know.
Well said. That's a great point. There is such a thing as being wrong. And,
sure, of course.
And that person's experience doesn't make it right. So, and then
so Mr. Balder, I don't see it.
So Stringer News 1 says, Darryl, perceive isn't a synonym for imagine.
What's that?
Perceive is not a synonym for imagine.
I agree.
All right. Mallory is debating next week. 1 week from today, she will debate Flower of the Land at 8 p.m. Central Time. It's gonna be sparkly. What do you think? Sparkly? Should we have a sparkly debate? She says, think of the future. Do not vote for Mr. Pebbles. Mr. Pebbles is apparently a cat going to space.
Sounds like a cat. Yeah. A lot of cat names.
Yeah, nobody's guessed it yet that I saw. Warren Evans says, if Darryl hasn't seen it, therefore doesn't exist. If he has never seen the White Cliffs of Dover, they don't exist.
I've seen the White Cliffs of Dover.
Oh, they were spared.
I saw them.
They were spared. Have you seen the London Eye? Have you seen the London Eye?
Yes, of course. I've been in London many times. Yeah.
Eiffel Tower.
It's usually raining.
Eiffel Tower?
Of course. I was at the Eiffel Tower when I was 18. That's my first visit.
Burj Khalifa.
Burj Khalifa? Yes. I mentioned that in the debate, remember?
Yeah, but you saw it yourself.
Yes.
Excellent. How about the Statue of Liberty in Las Vegas?
Yes, been to Vegas.
Okay, what about the Cherry on a Spoon in Minneapolis?
Never been to Minneapolis.
All right, well then it doesn't exist. Dang it, I just saw it the other day. Saeed Ahmed says, with the Earth being flat, can low-budget Will Smith see Bel Air from his location? They think you look like Will Smith. I think that's a high compliment, I think.
That's not the first time I've heard that.
Oh, Will Smith is one of my favorite actors. I just love him.
Yeah. Will Smith is good. Yeah.
I use his for after shows. I use different things from Will Smith, typically Fresh Prince, and just because it's a silly thing that I do for after show thumbnails. So can you see Bel Air from your location? If you got it in a balloon high enough, do you think you could see Bel Air with a telescope?
From a balloon?
From Ghana, yeah, from Ghana there.
High enough, no.
What if Will Smith jumped in a balloon and also went up to a high elevation? Could you just look across the air between you and the real Will Smith and wave at each other, and he'd say, "That's me"?
It depends on where he is.
Well, a Bel Air, but he's in a balloon directly above Bel Air.
Not from my location, I wouldn't see him.
Why not?
Because the horizon would be in the way.
No, but if you're both in a balloon and you're both really high in this balloon, could you see each other then? Could you wave at each other if you had a telescope?
Sure. Yeah. I mean, are we saying in the same country?
No, you're in Ghana.
Okay.
We covered that already. And Bel Air, he's in Bel Air, where's Bel Air?
What, in California?
There you go. So you're in Ghana, he's in California.
He's across the ocean. Wouldn't see him.
But you both go up really, really high in a balloon.
Wouldn't see him.
Why not?
Horizon's in the way. Can't see it.
Why would the horizon be in the way if it's way below you? Say you went up to 200,000 feet. Why would the horizon block your view?
Eric Baumgartner on his historic jump, he was at 128,000 feet. He had a horizon. He couldn't see beyond the horizon either. There's always a limit. As
predicted on a globe, but on a flat Earth, the prediction is that you'd be able to see each other.
No, you wouldn't. Perspective.
It's just a buzzword. All right.
Perspective.
John Rapp says...
Neil deGrasse Tyson said that stuff's flat. You can't see two centimeters off this beach ball, right? That stuff's flat. Okay, well, that's
but he didn't say perspective. But all right, anyway, John Rapp says anyone who can see the moon anywhere on Earth will simultaneously see the same face, shape, and phase. Please explain.
Same shape. Same phase. That's not true. I think the phase does.
Everybody sees the same phase.
I believe the phase does switch.
What you like somebody will see a crescent and somebody will see a full moon at the same time on the same day?
No. I mean like
that's phase. That's the phase. So here's an example.
No, I mean like people have seen like like you have like the like what looks like a bunny rabbit in North America. By the time it gets to Australia, the bunny rabbit is upside down.
Yeah, that's not phase. That's just orientation.
Yeah, but
so he did not include orientation in the list.
I'm saying that it would shift.
I completely agree on both flat and globe. That is one thing that a lot of globe proponents get wrong. So, but he said face, size, shape, and phase. So here's the example.
Everything would be the same? Is that what you said?
That is what we observe. So right here, I put the moon here. Can you see that? Mm-hmm. So you got somebody here in Ghana, maybe, right? Well, you're farther over here, right? Yeah. So maybe let's go Namibia, and then somebody in, let's say, Indonesia. They're on kind of on opposite sides of the moon. Now, both of them see the same size, shape, phase, and face of the moon, but on flat Earth, that would predict that you'd see generally the opposite side of the moon. So one would see different phases and certainly different parts of the moon. Why do they only see the same thing?
I don't know that to be the case. I thought they switch.
So you're claiming that they don't see the same phase, size, shape, and okay.
I think the phase would switch. I don't know that for certain. I have to look into it more.
So,
I'm a little fuzzy on that one.
That would be a good thing to look into. But everybody sees the same phase.
Okay. I'll take your word for it at this point. I can't argue it.
All right. Let's see. Just a second here. All right, I'm gonna have to end this here pretty soon here. What time is it there? It's getting kind of late
Can
for you.
you tell us what emotions you had?
All right.
Yeah, it's 1 o'clock.
All right.
It's 1 a.m.
1 a.m. Oh, I appreciate you staying up. All right.
Oh no, wait a minute, wait, no, sorry. It's 11. It's 11. 11. Sorry.
11. Okay.
11 p.m.
Stringer News One says the good news, you look like Will Smith. The bad news, it's Will Smith in Hancock. I like Hancock. What's wrong with that Hancock there, Stringer News One?
I like Hancock. I like
too.
Hancock. It was
right.
okay. It was funny.
High five on Hancock.
Okay.
You got it. There we go. All right. Warren Evans says, how do tides work on the flat Earth?
What's that?
How do tides work? Why? What causes the tides to rise and fall?
No, tides. Okay. Tides. That is caused by the what is that? That's the electromagnetic pull of the alignment of the sun and the moon. You get high tide. It depends on the location. You get high tide twice in some places, and you get high tide only once in some locations. Depends on the location. But basically, the sun and the moon come into alignment, and the water rises.
Are
when
you
they come
sure?
at disalignment, it falls.
Are you sure it's not just the gentle rise and fall of the bosom on the deep? Bosom.
There is some effect. Of currents and
because that's what Eric Dubé says. I just can't get past that.
I disagree with Eric Dubé on that point.
He said bosom. So are there measurements?
On that one.
Are there measurements of this electromagnetic variation that causes it?
There is. Yeah, the water is. So all water is naturally diamagnetic.
Okay.
Salt water is even more so. It's that effect is intensified.
Okay. That wasn't my question though. My question is, are there measurements of this varying electromagnetic field?
Measurements, not to my knowledge, no.
Okay. Because the magnitude of the variation, being that water is diamagnetic, not ferromagnetic, the quantity of the variation of the magnetic field would have to be massive to cause that to happen, and we'd actually measure none.
You would have to detect it. You're telling me you don't detect it.
Well, you made a claim that it is so is there maybe a peer-reviewed paper that confirms?
Well, there is not. No
peer-reviewed paper.
That's what I understand. I haven't tested it. I don't know.
I've not. Yep. Okay.
That one I'm not so sure about. I'm just answering the question to the best of my ability.
Okay.
At this particular moment.
So and now earlier you did say, I just want to clarify, you're certain. You're like you have no idea, no possibility that this could be wrong.
What, you mean the shape of the Earth?
Yeah.
I'm absolutely certain. Yeah.
Got it. Okay.
I haven't experienced the ball. You tell me there's a ball there. I haven't seen it. Haven't experienced it.
Okay. Andreas, I thank you for that. Andreas Held says, anyone from south of the Tropic of Capricorn in the chat, does the sun set slightly north or slightly south of due west this time of year? It's a good question. The answer is it sets slightly south of due west.
Okay.
So and
yeah,
I'll do this.
Yeah, the Book of Enoch talks about the 6 gates. It's not always in the same place.
So here is, for example, the sun. No, don't be confused between the sun and the moon. This is the sun because it's red, and this is the moon because it's red.
Okay.
So the sun here, and now this is Australia. So sunrise about this time of the year when the sun is getting nearer the Tropic of Capricorn would be at this angle. I'll draw this out here.
Mm-hmm.
And then this line here, this line here is due east right here.
Yeah.
Okay. The sun is here, according to this map, at this time of year at sunrise. So this is due east, so that it would rise, according to this map, north of due east. In reality, it rises south of due east on the opposite side there. Why is that?
When is this? What time of year?
This time of year. The time of year that is this. For example, in the chat, we've got PhD Tony, who is in Australia. And we currently store Australia south of the Tropic of Capricorn mostly. So in reality, the sunrise is the opposite of this. It doesn't match the flat Earth prediction. Therefore, flat Earth falsified.
Therefore, Earth can't be flat.
Yeah, well, at least this map is falsified.
Well, the map is falsified. I still don't experience the both.
So
Maybe the map. There are problems with that map, so I don't have a problem with you falsifying the map.
I do agree with you there. Okay.
No problems with the map.
So Tommy Gronwald wants me to play this this video from Wade's Underworld, who is an Australian. I hear some like noise in the background.
Oh, is that
Like,
me or you or what?
I think it's you. It's like some typing or something. It's okay. I'm just.
No, it's my fan.
Oh, okay. All right. There's that. I need to share it with you. Where'd it go? There it is. So here is Felix Baumgartner being interviewed.
Can you tell us what emotions you had?
Well, when I was standing outside that capsule, it was a very quiet and peaceful moment, you know. At that moment, you look at the world, it looks very fragile. You could see the curvature of the Earth. You could see the curvature of the Earth. I could see the sky was pitch black up there. And at the same time, you realize that everything around you is hostile. That means...
All right. I don't want to do too much because the Red Bull does a copyright strike on that pretty easily.
I didn't hear anything.
Oh, you didn't hear him say it? Oh, I wasn't piping it to you? Okay,
I didn't hear anything.
so Felix Baumgartner was interviewed, and how did it feel when you were looking out the capsule? He said he could see the curve of the Earth.
It's not what I observed in his video. The inside camera did not show any curvature whatsoever.
But his observation, his personal observations say it's curved, and you're saying that your personal observations, when you've not been to that altitude, somehow trump that.
I have photographs. I have a flat horizon. He can say he saw a curvature all he wants. I have a flat horizon. In the photographs that weren't fisheye. All the photographs I have of his jump that were not fisheye are flat horizon. The inside camera in his pod was not a fisheye lens. That was a flat horizon. I have another photograph at a different angle. I see a flat horizon. That's what his other cameras that were not fisheye, that's what we see. I had the photographs in my phone.
All right.
So he can say he saw the curvature of the Earth all he wants to. In fact, Neil deGrasse Tyson said, "Hey, that stuff is flat. You can't see 2 centimeters off that beach ball. It's flat."
Yeah. So the guy that was actually there, said he saw the curve.
Propaganda. He's pushing propaganda. Neil deGrasse Tyson said that stuff is flat. I saw it flat.
So it's propaganda when it disagrees with you, and it's okay when it doesn't disagree with you.
I'm saying what Neil deGrasse Tyson said at 128,000 feet, that stuff's flat. You've seen the video. I know you've seen it.
Oh,
That's
yeah,
what
yeah.
I see. I saw the
All right. So
the inside camera of his pod that was not fisheye had a flat horizon. I have another photograph that's not fisheye. That's a flat horizon.
But we've already gone through that. You're not very good at
I've seen it.
testing a hypothesis, right?
I can see what I see.
But you test a
I see what I
hypothesis.
see. I have the photographs.
But you test a hypothesis. You do science. You
I
test
see
a
what I see.
hypothesis. Hold on. You take your hypothesis and you calculate the ramifications of it. So how much, based on the width of the view, how much curvature is predicted, and is that much curvature what you saw? You did not do that. You did not run that through the scientific, anything science, and
there was a flat horizon.
Yeah,
in the photograph.
And how much
In the
curve?
photograph that I saw.
How much
there was
curve?
No atmospheric conditions. There was
How
none
much
of that. It was
curve?
flat.
How much curve should there have been? How did you quantify the amount of curve?
There was none.
But how much is
Zero.
predicted?
There was zero.
This is testing a hypothesis. How much curve is predicted? You don't know. So you don't know if you should see curve or not. That's the
But
problem.
there was no curve. You're telling me he saw a curve. I didn't see any curve in the photograph. That's
But
what I'm
he
saying.
had his eyes had a different
Said
view.
it's flat.
His eyes had a different view than the camera.
It was at eye level. It was at eye level.
Okay,
right?
changing the topic there when your hypothesis,
It was at eye level.
you
right?
did not test your hypothesis. You also did not measure
I have a
eye
photograph.
level.
I have a photograph.
So-
It's a flat horizon.
so
I have
you-
two of them.
But you don't know how much you should have seen. You did not test the hypothesis. This is the anti-scientific method. This is
It
the
was
pseudo
flat.
this is the pseudo-scientific method that you're going through here. You're starting with your conclusion. You're searching for things that support it, and you're not testing anything. That's all you're doing. That's not how you do science.
There was no curvature.
That's not how you do science. You're just
There was no
repeating.
curvature that I observed.
That's just your mantra again.
It's not a mantra. It's what I observed.
But you
It's
keep.
not a belief. I observe what I observe. It's not a mantra.
But Darryl, you keep saying it like a mantra. Every time you get cornered that you did
I
not.
see what I see.
Every
I
time.
observe what I observe. I
Yeah,
experience what I experience.
That's your mantra. Every time you get cornered that you did not test your hypothesis, you go back to your mantra. Don't go to your mantra. Go to science.
That's not a mantra.
Test things logically.
Well,
Darryl.
that
You're
is what
not-
I experience. What I
You're
experience.
not applying
Isn't it-
logic.
Isn't science about observation?
No, you're not doing a scientific observation. You didn't have a
Yeah, but aren't
hypothesis that you
Yeah,
tested.
but isn't science about observation and experiments and testing? I
You-
get that. That's cool. But
You don't want to do science. I understand. It contradicts your pre-selected conclusion.
it's not a pre-selected conclusion. It's what I experience. It's not. I'm walking around.
But
I want to experience the flat Earth. I experience what I experience.
But Darryl, you
I'm
did
not
not
walking around.
test.
I want to experience the flat Earth. It's what I experience.
You did not test. You just went, Earth look
I
flat,
do not
therefore
experience.
Earth is flat. That's all you
Yes.
have. That is
Yep.
anti-science. And if you want to declare that science is something that you hate, then do that.
I do
and
not hate
stop,
science.
and
I'm not a
stop,
science hater.
but stop using things that science has produced, like cell phones and airplanes and clothing.
Okay. All
Right?
right, there you go. With this fallacy. Look,
to be
I
consistent.
don't believe NASA is telling the truth. Right? Okay. So does that mean
I never once
malfunctions?
cited NASA.
I'm just
I mean,
saying.
I've got the shirt
Okay,
on
right.
because
So
it was a gift.
So does that mean
I
should
never
stop using my
cited-
mobile phone?
I never cited
I
NASA.
should stop using.
You should stop using the products
My
of
car.
science. If you
I should stop using. My,
yes, you should stop using
my
those.
YouTube.
You should
I
stop
should
using
stop
the
using
products of
whatever.
science.
No, I don't. It has nothing to do with NASA not telling the truth.
It has nothing to do with NASA
It has
at
nothing-
all.
It has nothing, it has
NASA has
with
nothing
NASA
to
not
do with this conversation.
Oh yes, they do.
I
Because they
never
are the ones
cited,
for the CGI photographs. They're the
I
ones for
never
the CGI
cited NASA.
photographs.
but you,
Okay, well you're wearing a NASA T-shirt.
yes, because
You're walking around citing NASA.
because it was a gift, and I
Okay, I
intentionally wear it when I'm doing live streams to
I
trigger
got
the
you.
flat
And I'm
earthers.
saying, from my observation of Baumgartner's jump, all the stuff that was not fisheye was a flat horizon from his pod. Here's
Yeah.
another camera angle.
Daryl, stop saying
That's
it.
another
I don't want to
example.
hear it anymore because you did not test a hypothesis. It's
Okay,
not
I saw
science.
what I saw.
It's just
I
a
saw what I
religious.
saw.
It's just a religious claim.
Science is also about observation, is it not?
Observation is a part of science.
Okay.
It's not.
A very
You
important
start
part.
with observation and end once you have observed the thing that you want it to conclude.
I did.
You use observation as a tool in science.
Okay. But you don't disregard it. You don't be like, okay, what you observe doesn't matter. That's ridiculous.
Absolutely. But you did not then test your hypothesis. You should do that. All right. I want to move on because Bosom of the Mighty Deep has said, please don't laugh at me. Somebody changed their name to Bosom of the Mighty Deep.
You got some strange.
Oh my gosh. All right. William TM says, has a flat earther ever claimed we live in a hyperbolic space to try to explain how the map works? That would be far out. A hyperbolic space. I have an idea. I have an idea for flat earth. They're going to steal it from me. They totally are.
That's far. That's a far out idea.
Warren Evans says, why can we measure the tidal rise and fall in freshwater lakes if only salt water is magnetic? Or is this another, if you haven't seen it, it doesn't happen?
All water is diamagnetic. Even water that's not salt water.
Okay.
So all water is diamagnetic. All of it would be affected, but salt water would be more greatly affected.
Yeah, it's a good point. Water, whether it's salty or not, is, but as you said, it varies its magnetic permittivity and susceptibility. So, but the thing that's lacking in your example there, of course, is an actual measured change in the magnetic field.
I haven't tested it. I don't know.
So, all right. Well, if you don't know, then just say don't know instead of making something up. Maybe it's a more honest position. Darryl, it's a more honest position. If you don't know why, then and you can't support it with evidence, then don't make the claim. Just say don't know.
Okay. All right.
It's more fair, and you won't get yourself, and because you trapped yourself, because I know there is no magnetic field that varies. And I know that, because if there were, our compasses would go crazy when that happens.
Yeah, I got you. I get that.
Yeah, so I want to help you out here. Don't make claims you don't know about. Just say I don't know. That's much better, and then we can move on to other stuff. So, all right.
Got you.
Holy Small says the camera in the Red Bull pod does show curve. The horizon is not at the same level as the door and window. I did a video on it. So Holy Smalls has a video on that showing it. Maybe Holy Small, send me a message. I'll forward that video on to Darryl. John Rapp says, I call Poe perceived observation by English. Oh, there.
Okay, that's cute. I got that. All right,
and one more. This will be it from this is funny. I love this name. Merp says, if they are covering up the shape of the earth, what else are they covering up? Added up, there are more people in on all these conspiracies than out. And for centuries.
Am I supposed to answer, or is that just an observation?
I think it's a statement there. If you have a response,
is that just a defense mechanism observation?
I guess if you had a response to that, go ahead.
Well, I mean, it's not that difficult to understand if you have a conspiracy that lasts for several hundred years. It's not as strange as you think. If all of it comes from the Catholic Church, which I believe it does, all starts with Copernicus, Newton, and all these guys about 400 years ago. So they've had a lot of time to consolidate power.
But people have known the Earth as a globe longer than the Catholic Church has been around.
Everybody knows the Earth is flat and they're hiding it. That's not our position.
But Darryl, people have been saying that the Earth is a globe for longer than the Catholic Church has existed.
You mean 2000? You mean like the Greeks?
Yeah.
They
were not Catholic.
They had some speculation. They had some speculation that the Earth might be a ball. They didn't know it.
They measured the radius. Eratosthenes, Al-Burundi, they measured the radius.
Eratosthenes, the whole Eratosthenes story is a myth. It's not true.
So say you.
I've looked at the original source. It does not say anything about a sphere. I've looked at the original source. That story came up about 600 or 700 years after Eratosthenes' time, and it does not say sphere. I can give you a link to the blog. A historian of science who is a globe believer says that story didn't happen.
All right. Well, here's an interesting book I've been working through. I'm not too far into it. This one here called "Inventing the Flat Earth: Columbus and Modern Historians." So it's commonly thought that Columbus era people thought the Earth was flat. That's not the case.
That's not the case. Yeah.
Columbus did not think the Earth was flat. Columbus kind of intentionally misinterpreted and misrepresented the radius of the Earth to get approval for his trip. If he had been right and that the Americas were not between Europe and India, he would not have made it. They would have starved to death before they got there. So he lucked out. He lucked out by getting there. Anyway, this one, chapter 2, which is what I'm on right here. Chapter 2 goes back through history, analyzing different historical documents and identifying when different cultures identify the Earth to be spherical. And so far I'm back to about 1000 AD in the particular chapter I'm reading. So it's a good book. I in fact I emailed Jeffrey Burton Russell, the author. You said
about 1000 AD?
That's where I am right now in the chapter, and it's going farther back in time throughout the chapter. I emailed him, and he responded. I asked if he wanted to come on. He said thanks, and he appreciates what I'm doing. But he said he's 87 years old and just can't do interviews anymore. So
no. Okay, so you're saying
nice guy, though.
What you mean? People just.
I'm saying that
people stop believing the Earth was flat around 1000 AD. That was saying.
No. I'm saying that's as far as I am in the chapter so far.
Oh, okay.
The chapter isn't over yet, so it's going to go farther back. The point is, this is documenting, and I've looked up some of the citations because it's a well-cited book. This documents different writings by different people when they spoke about the shape of the Earth being spherical. So that's the point of it. I'm not to Eratosthenes yet in this particular book. But I suppose I will. I'm guessing. I don't know. All right, I got one more.
What's the name of that book again?
Inventing the Flat Earth.
Inventing the Flat Earth. Man, who's
Columbus and Modern Historians.
No. What's the name of the author?
Jeffrey Burton Russell.
Jeffrey Burton.
Yep, yeah. Jeffrey Burton Russell. And it's not very big, and so it's a pretty easy read. Pretty quick read. Well written too. I appreciate his writing style. Yeah, some cool stuff. He's got some pictures too. So yeah. Anyway, one more says. Tim Pryor says, so when Neil deGrasse Tyson says it looks flat, no question asked. He says a globe. Nuh-uh. So when Neil deGrasse Tyson says it's a globe, that's what you get, huh? All right. Well,
I'm saying that Neil deGrasse Tyson disagrees with Eric Baumgartner. Then if he's saying he saw curvature and Neil deGrasse Tyson disagrees, I disagree too.
All right. Well, Darryl, I appreciate that you came on. It's been a good talk. So
I've learned some things.
Anything? So I sent you, and I'm happy to send you anything else, any other citations. Anything you want to say as we kind of wrap it up here?
I'd like to thank you for having me on. I'd like to perhaps we should do this again sometime.
Sure.
I need to tighten things up.
Good. I'm always happy to have a tighter debater.
I'd also like to put forth that this is my first public debate on YouTube, so I think I did okay.
Okay. Let's see. Matt Klein.
Thank you.
Matt Klein said he's got kids to take care of and a parent and all that. Thank you very much, Matt. And everybody else, I definitely appreciate the super chats. But it's absolutely not necessary. I'll interact with you and read stuff all day long, and I appreciate it so much. And like Matt was saying, sharing stuff on Facebook, Twitter, wherever, that's a huge help. And so that's what I would ask for. That's all that I'm going to ask for. So anyway, later, let's see, about an hour and a half from now, I have round 2 with Josh Hamer. I had him on a while ago when I was on vacation sitting in a park, and it got dark. And so I was sitting in the dark talking to him, but we'll be in the light today. So anyway, thank you, Darryl. We'll see you around on Facebook, I'm sure.
I'll see you around, Batoon.
Yep. All right.
It's been a pleasure.
All right, everybody. Thanks a lot. We'll see you in a little bit. Bye.
Bye.